Okay. I'm not sure if you can hear me. I'm trying to figure out how to monitor the chat. Can anyone hear me? Testing, testing. I can't figure out how long the lag is. Okay, hold on. I'll just move this and then watch. And okay, so I don't have a clock. There we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, there's like a 20, oh, even longer, 25, 30-second lag. That's more than I would prefer, but I'm not entirely sure how to fix it, if that's possible. In any case, hello, those of you in the chat. I am giving this a shot because it's been difficult to find the momentum to make any more videos, and while my schedule is going through a disruption, I figured it might be a good opportunity for me to try it out and put something out there, even if it's not a pre-recorded and edited video. I prefer those, but I think it sort of has to be something like this. Yes, I was counting the delay. So on my end, it's about 30 seconds, and I don't know if latency changes from person to person. It has been a very long time. I do regret that. I made several attempts at making more content over the years, and none of them, they never completed. They just, it didn't work for one reason or another. But it's always my intention to keep trying. So whenever it works, it works. And today, as I was kind of running around my small apartment like a chicken with my head cut off, I found a book on my bookshelf called Synaptic Self, which is a book about studying neurobiology with an intent to get some information as to how neurobiology and consciousness are linked. How neurobiology generates consciousness, that sort of thing. And It's been a while since I've read something like this. So I think it seems like a good time to try. Sorry for the delay. I'm just trying to figure out where to start. I guess I'll just start at the beginning. I don't know if I'm going to skip around or what. But here we go. Chapter 1, the big one. I don't know, so maybe I'm not, the t-shirt said. Had it been another time or place, I probably would have chuckled and moved on. But I was on Bourbon Street when this postmodern homage to Descartes' proclamation, I think, therefore I am, appeared on a young man weaving toward me. I had just had dinner in the French Quarter after a long day of data digestion and schmoozing at the Society of Neuroscience Conference, an annual get-together of 20,000 or so brain researchers from around the world. The sound of Dixieland tunes, the aroma of stale beer, and the sight of scantily clad women dancing on runways inside dark bars had me contemplating the years and life changes that had come and gone since I myself had weaved down Bourbon Street during my college days in Louisiana. I headed back to my hotel, reflecting on my past and present life and wondering about what, all of a sudden, seemed to me to be the big question brain researchers should be asking. What makes us who we are? Neuroscience hasn't yet delved deeply into this puzzling issue. It has, for good reason, focused on how specific processes like perception, memory, or emotion work in the brain, but much less on how our brains make us who we are. I'd venture a guess that if a random sample of neuroscientists were asked, what do we know about the brain mechanisms of the self and personality? The predominant answer would be not much. But maybe we know more than we think. Maybe some or even many pieces of the puzzle have already been discovered and just have to be assembled into a coherent whole. Actually, I believe this might be the case. A lot of information is available about how the brain works, and while it may not yet be sufficient to fully explain persons, it should certainly encourage us to begin thinking about the problem. My notion of personality is pretty simple. It's that yourself, the essence of who you are, reflects patterns of interconnectivity between neurons in your brain. Connections between neurons, known as synapses, are the main channels of information flow and storage in the brain. Oh, and then there's a picture. You know what? I'm going to try to get the picture on the screen. I don't know how successful I'm going to be with that. I need to take the picture, pull it up somehow. Maybe I can make a very small window over here. And it will appear in my cloud at some point. Maybe. Okay, there we go. And then I'll just save that. Yeah, oh. That's not as high res as I thought it would be, but that's okay. This is the diagram in the book, and let's see. Demonstrating the connections between neurons, known as synapses, the main channels of information flow and storage in the brain. So we have here I think the triangle there is neuron, S for synapse perhaps. So that's maybe one demonstration, and then this is like a physical demonstration. Synapse, dendrite of receiving neuron, terminal, incoming nerve fiber. Oh, and it's got some text as a caption. Synapses are small gaps between neurons. When a neuron is active, an electrical impulse travels down its nerve fiber and causes the release of a chemical neurotransmitter from its terminal. The transmitter drifts across the synaptic space and binds to a dendrite on the receiving neuron, thus closing the gap. Essentially, everything the brain does is accomplished by the process of synaptic transmission. A picture taken on an electron microscope of an actual synaptic connection between two neurons is shown on the bottom here. So I think it's low res just because it was just, I'm not sure, but that is taken from a microscopic photograph. So that's cool. I just saw your question, Tech Tom. It would be easier to use a webcam. I don't own a webcam. And I don't know if I will anytime soon. And however, I would assert that in a video like this, or a video that's here for relaxation, there's no need to hurry or be efficient in what I'm trying to do. I read a book once that was, sorry, my chair is squeaky. I read a book once, it was fiction, but it was a fiction about a sort of a religious cult that they worshipped by being inefficient. They said that God existed inside of liminal space, and so with every activity they did, if they wanted to I don't know, pray, I guess, they would create longer liminal spaces by being inefficient. And I'm not religious by any means, but I really liked that idea. It's sort of resonant. I could cast from my phone as well, but I got this microphone. I'm sure it sounds fairly average, but for a long, long time with my videos, I was only using my phone audio or my tiny, tiny cheap recorder, and I would really like to have, a little bit better audio. I've become more picky. I just saw your comment, Tech Tom. Yeah, don't read books. They're dangerous. I'm going to continue on with this book, though, and I'll leave it to you to answer the philosophical question of whether listening to a book being read counts as reading. Most of what the brain does is accomplished by synaptic transmission between neurons and by calling upon the information encoded by past transmission across synapses. Given the importance of synaptic transmission in brain function, it should be practically a truism to say that the self is synaptic. What else could it be? Not everyone, however, will be happy with this conclusion. Many will surely counter that the self is psychological, social, moral, aesthetic, or spiritual, rather than neural in nature. My synaptic theory of the self is not proposed as an alternative to these views. It is, rather, an attempt to portray the way the psychological, social, moral, aesthetic, or spiritual self is realized. I'll state unashamedly from the start that we can't, at this point, go all the way in formulating a complete synaptic theory of personality. But even a partial understanding of the synaptic basis of who we are is, for me, an acceptable goal. For seeking knowledge about the brain is not only a valid scientific pursuit, it can also improve the quality of life, as when it uncovers new ways of treating neurological or psychiatric disorders. Synaptic nature. Let's start with a fact. People don't come pre-assembled, but are glued together by life. And each time one of us is constructed, a different result occurs. One reason for this is that we all start out with different sets of genes. Another is that we have different experiences. What's interesting about this formulation is not that nature and nurture both contribute to who we are, but that they actually speak the same language. They both ultimately achieve their mental and behavioral effects by shaping the synaptic organization of the brain. Oh, there's another figure. The particular patterns of synaptic connections in an individual's brain and the information encoded by these connections are the keys to who that person is. Okay, sorry, I was just taking a quick photo of the next figure. You know what? I think what I'm going to do is I'm going to take a few minutes here and take some pictures of the next few figures so that I don't have to get them one at a time. So I guess I'm seeking some efficiency, but hopefully not in too rushed of a state. I went into the next chapter and it looks like there's a lot more, or there's a lot fewer diagrams, and I think it's because it moved from science to philosophy for a little bit. From what I've read of this book, I haven't read the whole thing. It seems like a pretty admirable blend of the two. It is sometimes very difficult to combine philosophy with science. At least in a way that is purely rational. Oh. I forget that I have an accent too, and I have no idea what it sounds like. I And there might be times I mispronounce things. That's also a possibility. Okay, let's see. I think it's making these super tiny either because my image cloud service is not letting me download the full version, or maybe my phone is having a hard time. I don't know. I'm sure something is functioning differently than usual because there's so much network strain on everything. I'm putting more network strain on things just by streaming. There's sort of a conversation to be had there about what's responsible or not, but I sort of don't want to touch on that right now because wait, what a picture of me. Oh no, don't worry about it. I don't know what you're talking about. Okay. So what we see here now is it's discussing the philosophical question of whether our selves or our souls or our consciousness or whatever is created through nature or nurture. And I remember this chapter a little bit. It starts talking about in the questions that this person is investigating, there's not necessarily like either way, whether they derive from nature or nurture. They're expressed the same way synaptically. Actually, there's a small bit of text underneath that says that, but I think it's probably not high-res enough to see. Well, thank you. All right, where were we? The genetic blueprint begins to unfold in the newly fertilized egg. Genes actually do two things in the broadest biological sense. They make us all the same, we're all humans, and they also distinguish us from one another. Each of us has a unique genetic makeup that contributes to our individuality. When two people get together and make a baby, they always end up with a creature that looks and acts like a human, and not like a monkey, dog, or fish. The common genetic heritage of our species dictates that the basic systems and molecules in my brain are the same as those in yours. And the basic mental and behavioral repertoire available to me is also available to you. We all walk upright, speak through our mouths, laugh, cry, and learn from experiences. But as children of a particular set of parents who are themselves products of a particular genealogical history, we each also have genes that give our brains unique qualities and direct the specific manner in which the general mental and behavioral characteristics of our species are expressed. Genetic factors are in fact known to influence a variety of individual or personality characteristics, including how outgoing, fearful, or aggressive one is, as well as the likelihood that one will develop depression, anxiety, or schizophrenia. Just how do genes affect individual behavior? In the simplest terms, they do so by making proteins that shape the way neurons get wired together. There are many steps, to say the least, between genes and their expression in actual behavior, but genetic sculpting of the synaptic organization of neural systems is the key to the process. Animal breeders have long known that it takes only a few generations of mating among carefully selected individuals to begin influencing behavioral traits of their offspring, such as how tame or fierce a given line of dogs is. When breeders try to customize behavior in this fashion, they, in fact, are often working with the synaptic organization of the brain. A few extra connections here, a little more or a little less neurotransmitter there, and animals begin to act differently. Once we realize that the basic wiring plan of the brain is under genetic influence, it's easy to see how not only animals but also people can have very similar brains and yet be so different right from the start of their lives. Genetic forces operating on the synaptic arrangement of the brain constrain, at least to some extent, the way we act, think, and feel. The hopes of some and the fears of others surrounding the issue of human cloning obviously hinge on the importance of genes in regulating not only how we look, but also who we are. I think that's a good place to pause. I need to go get a glass of water. I should have got that before I started the stream, but I didn't think about it, so I will be right back. I'm back. I do appreciate the suggestion, Tech Tom. I don't know. I've put some thought into the kind of content that I would be most motivated to make. I think even if I do a video like that, I'll probably not make it a video of myself. There's a certain aesthetic about having having videos where all you can see are someone's hands, or I don't know, just kind of something depersonalized. It's kind of tough because like my favorite ASMR artists happen to be ones that film themselves. And I get a lot out of that. So it's like tempting to want to do the same thing, but I just don't think I don't know. I don't know. There's like an aesthetic thing that I'm not quite sure how to describe, but want to follow it, which might sound kind of silly. I have shown my face in a video before. It's been a long time. I don't think I look the same as much, but obviously I would look look similar. I don't know, maybe. All right, this next segment is called Nurturing Nature. The puzzle of how nature and nurture shape who we are is simplified by the realization that synapses are the key to the operations of both. Whether your paycheck is deposited to your bank account automatically or you hand it over to the teller in person, it goes to the same place. Nature and nurture function similarly. They are simply two different ways of making deposits in the brain's synaptic ledgers. For example, in life, and not just in cartoons, rodents really are afraid of cats. This is true of rats and mice living in the wild, but also of the rats studied in laboratories. Although lab rats come from breeding colonies that have been isolated from cats for many, many generations, any one of them, upon seeing a cat for the first time, will freeze dead in its tracks. This is Mother Nature at work, since the rat and his immediate ancestors never had the opportunity to learn from personal experience that cats are dangerous. This behavior is not just specific to rats or even animals, for people also freeze when faced with danger. Recall the amateur videotape of the bombing at the 1996 Atlanta Summer Olympics, shown over and over on CNN. Why don't I remember that? Within a second of the explosion, everyone in the vicinity was crouching, motionless. Holy cow. I don't think I knew that happened. Why did freezing become a genetically hardwired behavior? Obviously, there's no way to know for sure, since we have no fossil record tracing the evolution of behavioral or mental capacities. However, a reasonable hypothesis is that freezing is a beneficial response when faced with a predator. Predators, the primal danger for most animals, respond to and are excited by movement. Keeping still in the face of danger is often the best thing for the prey to do. Because millions of years ago, animals who did so were more likely to survive. Today, it's what most animals do, at least as an initial line of defense. Freezing is not a choice, but an automatic response, a pre-programmed way of dealing with danger. It sometimes backfires, however, as when a deer is frozen in the headlights of an oncoming car. Like most evolutionarily based strategies, it's good for many animals much of the time, but not for all animals all of the time. What's interesting is that freezing also occurs if a rat, or other animal, merely hears a sound that preceded an aversive stimulus, a mild electrical shock of its feet, on some prior occasion. There's no predator around in this case, so how is the connection formed? The sound is a warning signal. Any rat that survives an encounter with a cat or other predator should store in its brain as much about the situation as possible, so that the next time the sounds or sights or smells that preceded the arrival of the cat occur, those stimuli can be attended to in order to increase its chances of staying alive. In the case of the electrical shock, pain receptors are activated, and this substitutes for a close encounter of the harmful kind with a predator, making it possible for the stimuli that preceded the shock to be stored as if they were those that preceded a cat. There are two basic ways in which these kinds of processes might have been wired up in the brain. First, a two-system operation might exist, with one system for responding to species-typical, innate or genetically programmed dangers, and another for learning about novel ones experienced by individuals in their lives. Or there might just be one system that takes care of both situations. In fact, experiments show that the latter is the way the brain actually works. And then it references another figure. Okay, well, I figure out how to get that up here. And it's sideways, oh no. Fight, fight, or freeze is a weird instinct of all animals that haven't learned to accept a situation. It seems like the fight instinct might be valuable if there's a possibility of not having to accept a situation. Let's see, can I rotate this? Yeah, okay. Okay, so in this one, oops, it mentions both innate threats, which are like the threat of the cat. So I guess the rat smelling the cat, even if it's never encountered a cat before, it considers it an innate threat. But then there's also learned threats where an animal might come to associate various sets of stimuli with pain or some other undesirable situation. And those both feed into the fear system and produce defense responses. It strikes me that this diagram, I mean, it seems accurate, but it also seems incomplete when thinking about human fear systems, because most of our fears are social fears that are based on mimetic content. And so it seems like the fear system that governs those might be a different one than the ones associated, or a different one, or like a I don't know, some sort of adjacency to the system that handles like physical expressions and physical pain. But I don't know. No, the baby mice didn't take mice school. Where they were taught about cats, you mean? Oh, well, I mean, it could be a sort of a rats of Nim situation, right? Where the rats that were bred in laboratories, they all ended up becoming sentient because, I don't know, just their breeding and exposure to science, like, it accelerated their learning. I know you're avoiding books, but if you weren't, if you were going to make the ill-advised decision to read a book, The Rats of Nim is one that I can't recommend for being delightful and pretty intuitive. But you shouldn't do that. Okay, let's see. Damage to a region of the brain called the amygdala eliminates the tendency for rats to freeze to both the cat and to the sound. The amygdala is part of the brain system that controls freezing behavior and other defensive responses in threatening situations. Its synapses are wired by nature to respond to the cat, and by experience to respond in the same way to dangers that are learned about. It's a wonderfully efficient way to do things. Rather than create a separate system to accommodate learning about new dangers, just enable the system that is already evolutionarily wired to detect danger to be modifiable by experience. The brain can, as a result, deal with novel dangers by taking advantage of evolutionarily fine-tuned ways of responding. All it has to do is create a synaptic substitution whereby the new stimulus can enter the circuits that the pre-wired ones used. I wonder if that is relevant to my question too. There was another figure that it wanted me to show you. Let's see. Okay, here we go. So, I mean, this diagram is almost too obvious to include here, but I'll read the caption to it. Oh. The rats of Nim, I could read that. Oh my goodness. Maybe. Okay, figure 1.4, the amygdala, centerpiece of the defense system. The amygdala determines whether danger, innate or learned, is present, and if so, initiates bodily responses that were designed by evolution to deal with dangers. I wonder what the amygdala's calculations would look like if we could see those. Right. Okay, for the past 20 years, I've been trying to figure out how brains learn about dangers. In my previous book, The Emotional Brain, I described much of what is known about the organization of the brain system involved, and laid out the implications for understanding emotions. The basic wiring plan is simple. It involves the synaptic delivery of information about the outside world to the amygdala, and the control of responses that act back on the world by synaptic outputs of the amygdala. If the amygdala detects something dangerous via its inputs, then its outputs are engaged. The result is freezing, changes in blood pressure and heart rate, release of hormones, and lots of other responses that either are pre-programmed ways of dealing with danger, or are aspects of body physiology that support defensive behaviors. Throughout my past research, I've made use of the fact that the fear system can learn and store information about stimuli that warn of impending bodily harm or other dangers. Recently, though, my lab has turned to studies of exactly how fear learning takes place at the synaptic level. This new work, described in this book, sheds light on how synaptic modifications in the fear system, particularly in the amygdala, allow us to benefit from past encounters with danger. Most systems of the brain are plastic, that is, modifiable by experience, which means that the synapses involved are changed by experience. But, as the fear example shows, learning is not the function that those systems originally were designed to perform. They were built instead to accomplish certain tasks, like detecting danger, finding food and mates, hearing sounds, or moving a limb toward some desired object. Learning, synaptic plasticity, is just a feature that helps them do their job better. Plasticity in all the brain systems is an innately determined characteristic. This may sound like a nature-nurture contradiction, but it is not. An innate capacity for synapses to record and store information is what allows systems to encode experiences. If the synapses of a particular brain system cannot change, this system will not have the ability to be modified by experience and to maintain the modified state. As a result, the organism will not be able to learn and remember through the functioning of that system. All learning, in other words, depends on the operation of genetically programmed capacities to learn. Learning involves the nurturing of nature. I appreciate your suggestions, Tecton. I will have to figure out something for video. As it is, I'm just not very experienced with audio, video, like gadgets and tools, and I don't know how to combine my phone's video with this microphone's audio. It seems like a really trivial problem, and it sounds a little silly as I describe it, but I still can't for the life of me when I think about, how do I resolve that? I don't know what the answer is. I appreciate that. All my videos, I don't know, I enjoyed making them, and I enjoyed having that sort of I don't know, just input channel in the ASMR community. It was really good, but I was interrupted by a variety of circumstances. Actually, among other things, I quit my job, moved halfway across the country. I started a new career, and became very involved in a lot of other things, and just my lifestyle hasn't been, I guess, very supportive of ASMR stuff in terms of both physical circumstances, like quiet, the existence of quiet, and the pace as well. The pacing of my life is pretty intense, and it's hard to find a moment. Hey, Blackcurrant. Thank you. I appreciate that. I would love to do more ASMR, VR stuff. I don't know, video game stuff in general seems. I'm a little worried that it's overdone in terms of what kinds of videos are out there. But I don't know, virtual worlds is where I spend the majority of my time, so it would be interesting to figure out a way to make that compatible with videos as well. Oh, I also don't know how some of this sounds either because I'm not monitoring it, so that'll be something I figure out after the stream. Speaking of which, I think this has been a good experimental test. I got some still images working and my audio working, and that seems like the bare minimum of something I need. It would be nice to have some sort of live setup, but anyway, little steps, I suppose. Well, hey there, still there. Yeah, no, I appreciate that. Not at all. My interest in ASMR, like my ability to create content, has obviously waned, but like my enthusiasm for the format and the community and everything, is still pretty, still pretty solid. No, Tech Tom, not this time. That's very flattering. All right, it's been great. Thanks, you guys. I think I'll do this again soon. Maybe I'll schedule it beforehand first. I don't really know, but anyway, thanks, guys. Take care.